Hello friends, welcome to Electronics for You. In this video, I will explain branching instructions for 8051 microcontrollers. So, branching instructions are classified into three main types of instruction. The first one is jump instructions, second one is call instruction, and the last one is return instruction. So I have already explained call instructions and return instruction in my previous video, where I have explained the concept of stack and subroutine in microcontroller, especially in case of 8051 microcontroller, and there I have already explained a call instruction, L call instruction, then RET, that is return instruction, and RETI instruction, that is return with interrupt instruction. So we are only having these jump instructions in this video. So if you want to see call instruction and return instruction, please watch our previous video, otherwise keep watching. So here are the jump instructions, which are mainly classified into unconditional jump instruction and conditional jump instruction. The first one is unconditional jump instruction. As the name indicates, it is unconditional, means here there is no condition over the jump. Now what is the jump in the program, I will explain it later, but see, a jump to a new location from where the program continues execution is executed. Okay, so here the direct jump will be executed and there will be no condition while using this instruction. Now there are second group of instruction which are called as conditional jump instruction. Here jump to a new program location is executed only if a specified condition is met. Here one condition will be there. If that condition is satisfied, only then jump to the new location will be executed. Otherwise program normally proceeds with the next instruction. It means that the program will otherwise continue if the jump condition is not satisfied. So let us see some of the 8051 operands which will be used for the jump instruction. Here the first one is accumulator, then RN. Here it will indicate the register R0 to R7 from any of the register bank. Then direct will simply indicate the internal memory location, internal RAM memory location for 8051. Then at the rate, here in RI indicates the indirect internal or external RAM location. At the rate actually indicates internal or external RAM location. Otherwise RI is only related with the internal register which are located in registers bank R0 and R1. These are the two registers which may be in any of the register bank. Then hash data, that hash is indicating actually immediate addressing mode, and here data is actually 8-bit constant. Then address may be of 16-bit or 11-bit. Note here that this may be from the program memory. It is internal or external program memory. Then this is the relative address. I will explain it later in our video. And the next one is bit. Here bit means any of the IO pin or any special function registers pin which can be set or reset. And C stands for the carry flag in case of our PSW register, that is program status word register. So these will be the operand which can be used in our instruction. Now let us see unconditional jump instruction. The first unconditional jump instruction for 8051 is LJMP. Here it is followed by the address 16, means a 16-bit address. L stands for long and JMP is indicating jump. So it is a long jump instruction. Now it is a 3-byte instruction and this is LJMP is its first byte. Okay, and it will be followed by a 16-bit address. For example, our 16-bit address is 1234H, that is hexadecimal value. In this case, this 12 and 34 is actually second and third byte of the address. 1234 is only indicating the 16-bit address and not the constant. The 2-byte target address allows the jump to any memory location from 0000H to FFFFH. Note here that we are having this 16-bit address. Its lowest value may be 0000 and its highest value may be FFFF. Okay, because these are in hexadecimal, and therefore it will range from 0 to 64 KB, because FFFH is indicating 64 KB, which is nothing but 65,535. Now here, as we are talking about jump, now it is an unconditional jump instruction, means here no condition is satisfied, only the program execution will shift from the current address to this address. For example, if here LJMP instruction and it is followed by some address, and if we are having the memory address as 2039, 2041 and 2043 likewise, and if suddenly this LJMP instruction comes and LJMP is followed by some address, basically whenever we are writing this program in assembler, we write here any label. For example, we can write a label as next, which will indicate some address. In this case, we are talking about a 16-bit address 2050. So here the program counter will be loaded with this address, that is 2050, and suddenly the program will jump to the particular location. Here is the 2050, and therefore our program is jumping here. It means that program will further execute from this line and it will continue until the next jump instruction will come, or until the program get stopped. So this program counter is having a 16-bit address and it can jump from 0 to 64 KB. I have already explained it. Now next instruction, again it is an unconditional jump instruction, and it is AJMP address 11. Previously it was a 16-bit address, now it is an 11-bit address. It is very special instruction in case of 8051. Note here that A stands for absolute, so it is an absolute jump which is of 11-bit address. Now note that our LJMP instruction was of 3-byte instruction, because last 2 bytes were including the 2 separate bytes, but AJMP instruction is only of 2 byte, so it is a 2-byte instruction. Here the procedure is different. It is very important instruction because it is somewhat different, and it is specialty of 8051 microcontroller. Note that PCL, that is the program counter's lower byte, that is second byte of the AJMP instruction, will be like this. So we can say that it is our PCL, that is program counter's lower byte. It is, again, as we are talking about lower byte, it is of 8-bit, starting from PCL0 to PCL7. All these this address is written here, and all these 8 bits are used out of these 11 bits. So whenever we are talking about this 11-bit address, 8-bit is from the PCL. And note here that in case of the higher byte of program counter, that is when we talk about PCH register, here only 3 bytes will be used. So 8 from this and these 3 bytes, that is PCH0, PCH1 and PCH2, these 3 bits are used here in case of the PC higher byte. So 3 plus 8 bits, total 11 bits are there, and this 11 bits address will be used. And out of these remaining bits that are that is starting from PCH3 to PCH7, we can say that these will remain unchanged. Means if program counter is having this bit as 2000, say if complete address is 2000, then this lower byte will be here. Then as it is the 4 bits, that is 2, okay, that is indicating 0, then 0, 1 0, and 2000 is actually indicating 0. So all these bits, that is 0 0 1 0 0, will remain unchanged and it will be copied from the program counter, and only these 11 bits, these 3 bits from the higher byte and lower 8 bits will be used. 2 raised to power 11 is indicating 2 KB. Therefore the jump range only will be from 2 KB, from 0 KB to 2 KB. Okay, so this is to be noted. In case of LJMP, it is complete 64 KB jump, whereas in case of AJMP instruction, it is only a 2 KB jump. This 2 KB jump will be to the next address indicated. Okay, the next jump is very important, and it is SJMP, that is short jump. It is followed by this relative address. Now what is this relative address is very important. Note here that SJMP instruction is also of 2 byte and its range is actually of -128 to +127 byte. Okay, its range is only this one. Now how it is that, I will explain it. Okay, so first byte is the opcode, so SJMP is our first byte here, and the second byte is the relative address. Now second byte is the relative address, which is actually a signed binary. Note here that this 8-bit address is actually a signed binary number, and therefore it is having both positive and negative value, and therefore it can jump from -128 to +127. Here there are two types of jumping. One is forward jump, where the program will jump to the next location. For example, we are going in this way, line wise, let it be 1 2 3 4, and if our program execution will jump to the next location, any of the next location from this line, then it is called as forward jump. And if the program jumps to any of the previous line, then it is called as backward jump. The forward jump is actually a positive value, whereas the backward jump is the negative value, and it is like this. See here, forward jump is +127 bytes, whereas the backward jump here, backward jump is actually -128 byte from the current value of the program counter. Higher byte will remain as it is, and only lower byte will be considered as a relative address, and accordingly the program execution will jump. Here is the example of the forward byte. For example, here the 03H is the relative address. Okay, 03 is written in case of instead of this REL, that is relative address, and if the program counter is having 06 value, okay, relative address of the next instruction, which is 06. Okay, now this 06 and 03 will get added, and the addition is 09. Okay, now in this case 09 is the next address from this 6th location. Okay, current position for the program counter was 6. For example, 1 2 3 4 5, 6th is it is the 6th byte, and here the relative address is 03H. So automatically program will jump to the next location, that is 06 plus 03, that is the 09. Okay, here higher address may be 2000, for example 2001 002001, then 2002, and likewise. Okay, this is the forward jump. Now the next one is the backward jump. How the backward jump is taking place, let me explain. Here, if the relative address is F2H, Note here that f2 is the signed value which is indicating here. Okay, so f2 will be added with the current value. Let it be the current value of program counter is 15. Therefore, this 15 and f2 will get added. So here it is the hexadecimal addition. So 2 plus 5 is 7 and f plus 1 will be 10. Now note here that 07 is actually indicating the address. Our current address for the program counter was the 15. Current relative address is 15, whereas 07 is indicating the backward jump, means it will jump to the previous location from this 15, and here 1 will be dropped, that is actually indicating a negative value in case of our signed binary. Therefore, in this way the backward jump is calculated. Now who calculates it? So simply you need not to calculate it, because instead of this, say if you are writing a label, for example you are writing as JMP, you will not directly write the relative address in the assembler. You write here, say for example next, or you can write repeat, or you can write anything. Okay, label may be anything. So here the calculation will be done by assembler and not by you, but in this way actually assembler calculates the address for the backward jump or a forward jump. So you should note it. Okay, this is the relative address, and once you know the relative address, you can solve most of the problem. Next instruction, next unconditional jump instruction is JMP A plus dptr. Again, it is very important instruction, because it is used for the indirect addressing to access the data pointer. Okay, so here jump indirect relative to the dptr. Now how that take place, let me explain. If accumulator is containing 03 as its value, and if here dptr is loaded with 2000h, in this case this 2 will get added, and here it is indicating 2003h. Now this is the actually address of the indirect memory location, which is indicating now as 2003. So JMP 2003 will jump, program will jump to that particular location, means here the program will jump to the 2003 memory location indirectly. This is the unconditional jump instruction again. Now next one is the conditional jump instruction. So all these are the short jumps, because here the relative address is written everywhere. Okay, so all conditional instruction in case of 8051 are here the short jumps. Okay, now let me explain it. The first instruction is JC REL, jump to JC relative. Okay, relative address. Now JC stands for jump if carry flag is set. Okay, if carry flag is set, means if carry flag is 1, then the program execution will jump to particular relative address indicated here. Okay, and note here that again it is a 2-byte instruction. If carry flag is set, only it will jump, otherwise program execution will continue as it is. Okay, so next line will be executed directly. Exactly opposite instruction is JNC relative. Here it will jump on no carry flag. If carry flag is 0, then it will jump to particular location, otherwise it will program execution will continue. JB bit relative. Here bit is actually it may be a special function registers bit, or any bit in the 8051, maybe a port bit also. So here JB stands for jump on bit. If that particular bit is equals to 1, then it will jump to particular location, otherwise program execution will continue as it is. JBC, okay, jump if bit is clear. If that particular bit whichever mentioned, for example P 1.7 is mentioned, it means that port 1's 7 bit is there. If it is equals to 0, then it will jump to particular location, that is relative address indicated here, otherwise the program execution will continue. Next is again important instruction, that is JZ and JNZ relative address. Okay, so JZ stands for jump on 0. If accumulator's content is 0, that is if accumulator is clear, then it will jump to particular relative address indicated, otherwise program execution will continue. The next one is J and Z, that is if accumulator's content is not equal to 0, it may be any non-zero number, means 1 to FFH, anyone. Okay, if accumulator is having any of this value, then program will jump to the particular relative address indicated here, otherwise program execution will continue. Next instruction is again very important, that is DZNZ Rn comma relative address. Okay, here Rn is the any register of register bank R0 to R7. Relative address is I have already explained. DZNZ stands for decrement and jump if no 0. Okay, here decrement. What to decrement? Note here that decrement the register here. Okay, this is our destination register. First reduce this value by 1. Okay, decrement this value by 1, and if it is not a 0, if the register's content is not 0, then jump to the particular relative address, otherwise program execution will continue. Next is DZNZ instruction. Here direct is indicating the internal RAM location. Okay, so reduce this value by 1. If it is not equal to 0, then jump to particular relative address indicated, otherwise program execution will continue as it is. So these are the different conditional jump instructions. All these are related with the relative address. Okay, next one is conditional jump instruction. Again, it is very special instruction, that is CJNE. Here C stands for compare, J stands for jump. Compare and jump if not equal. Okay, it is compare and jump if not equal. Here we are having two different bytes, that is destination byte and source byte, followed by the address, because all these are the jump instructions, so relative address or any other address will be there. Mostly for conditional jump, relative address is there, and therefore REL is written here. Now in this case, okay, it is comparing two value, okay, destination and source, and if these two are not equal, then it will jump to particular location, otherwise if these are equal, then program flows continue with next instruction. Okay, so otherwise next instruction will be performed. Okay, but this instruction is again important whenever we have to find the largest number, smallest numbers, or we have to arrange them in the ascending or descending order. This instruction is very important because it not only compares and jump to particular location, but also it indicates the larger value and smaller value also. Okay, here the condition is if destination byte, this is destination byte, if destination byte is less than the source byte, in that case carry flag will be set. It means that if carry flag is set, definitely source is greater as compared to destination, otherwise it is cleared. Okay, and otherwise we know that if these are equal, it will the program continues with the next instruction. Also note here that destination and source byte will not get affected, it will remain as it is, only it will indicate with the help of carry flag whether source byte is greater or destination byte is greater. So CJNE instruction, these are the examples of CJNE instruction. Here accumulator and direct, that is actually accumulator and indirect direct RAM address, then accumulator and direct data byte here, then register and direct data byte, similarly indirect address and immediate data, that is direct data is there. Okay, all these here the left side operand is indicating destination, whereas right one is indicating the source. So source and destination is compared, and if they are not equal, the program will jump to the relative address indicated in the respective instruction. So there are 4 type of C, J and E instructions, and here the description is written. So all these were the different jump instructions. And friends, if you like this video, please subscribe our channel and press the bell icon for notification. And like, comment and share. Thank you.